not common. This is the slot where I mention some of the recent observations members have made and cover some things in the next few months happening in the sky. And since this is the last ordinary meeting for quite a while, I'll go forward for a couple of months in the summer and mention some of the ongoing observational programs that we'd like your contributions to. I really like this image from Nick Jones, Star Trail over Mount Etna, which he put on the BAA website. I think it's a very artistic one because
not a very artistic place.
He is. And you've got those clouds over the mountain, which and what looks like snow being blown off the mountain. And so the distinction between the earth and the sky is a bit vague, and then you can see the star trails going across those clouds as well, so it almost looks as if the stars are coming down to earth. I think that's a lovely production, with his relatively new Sony A7 camera that he mentioned, which seems to be one of the best cameras going at the moment. So, what's going on? What's going to go on? We're going to have a total solar eclipse on July the 2nd, and that's going to be over the Pacific and over Chile and Argentina, and quite a few people are going out to see it on the July the 2nd, and it is a sunset eclipse, so the sun will be low down in the sky, and it occurs right at the end of the day, and here is the, and this is, that is an animation which shows you the eclipse being happening, which is, oh, it is. So there's the dot of totality running across the Pacific and over the Andes, and you see it just about gets in there at sunset in the just south of Buenos Aires. There's another one next year in Argentina as well, which will be much higher in the sky. And 2 weeks after that, of course, we have a lunar eclipse. We normally get pairs of solar and lunar eclipses, and this one is visible to a considerable extent from here. Moonrise that night in London is 20:07 UT. The umbral eclipse will have begun just a few minutes before that at 8 o'clock, and the greatest eclipse is at 9:30, and then the umbral eclipse ends at about 11 UT. And so you can see that this is the area of the world where you get the umbral eclipse, and this is the area where the moon rises during the eclipse. So we hope for good weather for that one. Here's the phases of the moon over the next couple of months. Although I think it matters less at this time of year because people don't observe the moon so much in the summer because it's low down. And it doesn't affect light pollution so much either. It's not polluting the sky with light so much because there's light in the sky anyway, since it doesn't get dark astronomically between the middle of May and the middle of August. But here are the dates of the moon over the next couple of months. I thought I'd include a couple of moon shots because April and May were very good at months for imaging the moon, and I got some what I consider very successful moon shots in April. And this is when I particularly struck by this vast crater Bailey on the limb, which I took on April the 17th, and the way it distorts the limb, the way the far wall of Bailey is illuminated, and it just catches the light there, and all the surrounding areas are dark. It gives in my view on my computer screen, when I just saw that, it was very hard to understand how that could be a view of the Terminator, because you expect the Terminator to be a smooth curve, but it was very far from smooth there. And a similar example of an interesting illumination, that was May the 12th, and that's Clavius there. But Clavius is this vast gash in that image, completely unilluminated. And the big crater just above it is Maginus, and then we've got Tycho just at the top left there, completely in shadow. So, occultations, I'll mention, these are the brightest occultations over the next couple of months. On August the 24th, a quite well-timed occultation about 2:30 in the morning of a 3.8 magnitude star, Delta Tauri, and it's a disappearance of the bright limb with the moon 44%, a waning moon. And then on August the 27th, there's another star of similar magnitude, Delta Geminorum, and that is occulted at 4 in the morning. And then it's a thin crescent moon, another disappearance of the bright limb, and this is also a grazing occultation, and it's grazing on a line between the Wash and Swansea. South of that line, it's an occultation, and north of that line, there's no occultation. So that could be an interesting one to observe if you're in the Midlands, somewhere on that line, which is shown in the BAA handbook. And I'll mention on the subject of the moon, there's the Baker Street irregular astronomers who meet very near here in Regent's Park to do public observing, are doing a moon day, a moon observing event, and that's on Monday, June the 12th. So if you're in the area, and especially if you can bring a telescope along, come down and help the public observe the moon. And they get hundreds of people to these events, and an enormous variety, completely random demographic of people who would never otherwise go to an astronomical event, astronomical meeting, can learn something about astronomy. So that's their event, and you'll find the details of that, if you want, on the Baker Street Irregular Astronomers Facebook page. So it doesn't get dark this time of year, but one consolation is that it's the noctilucent cloud season, and the noctilucent clouds are best seen approximately 2 hours after sunset and 2 hours before sunrise, and they have been more active in recent years, even from southern latitudes. They have been seen more and more in southern latitudes, and nobody really knows quite why that is, and if there's a link to the solar cycle, it's not quite clear what the link is. The displays start in May and generally peak in the middle of June and end towards the end of July, and I've had some quite spectacular displays from London in the last few years. On one night, I was cycling home up the A5, and I saw all these people outside a pub, and they were all looking at the sky. I thought it was quite amazing. They all noticed on that particular night, it was so bright, the noctilucent clouds, that members of the public standing outside a pub had noticed it and were commenting on it. And that was about 11:30 in the evening. This is the first report that I've seen, or first observation that I've seen of noctilucent cloud this year, and this is from Scotland. This is from, I forget who it is, but it was observed in Alness in Scotland. But I haven't noted down the name of the observer. In the planets, I think the most excitement is associated with Jupiter at the moment, which comes to opposition in June, very low down in our skies. So, of course, the best images and observations we are going to get will be from southern hemisphere and from equatorial latitudes. And this is a recent image of Jupiter from Crisco in the Philippines. And you see some remarkable features, remarkable differences compared to Jupiter of other recent apparitions. You see the equatorial zone has gone this very dark colour, this brownish colour, and even more, that's the equatorial zone there, even more astonishing is the great red spot, which is looking like some sort of a tadpole or a sperm with with this material around it. And you'll see that there's some material here which appears this darker red material, and this spooled off the great red spot. And the great red spot in recent years is becoming smaller and more intensely red. It was so intensely red last year that even at the altitude that we observe from London, and indeed Regent's Park in this case, when I showed Jupiter to people using my 4-inch telescope at the Baker Street Astronomers, nearly everybody could see the great red spot, and they could see it as red, even people who've never looked through a telescope before. And that was with a very small telescope, with Jupiter only 20 degrees high in the sky. And here's an even more recent image. This is the 18th, so this is about 24 hours ago, from one of our very best and most dedicated planetary imagers, Clyde Foster in Centurion, South Africa. And he comments that the great red spot seems to have developed another flake here, another area of red material has flaked off. This is the material that flaked off earlier, and there is a narrow stream of material going around the top of the Great Red Spot. It really looks as if the Great Red Spot, I'd be careful, take this with a bit of caution what I say, but it looks to me like the Great Red Spot, it might be finally disintegrating after 150 years of observation. From the 1870s was the first definitely recorded observations, it's been getting much smaller, and now it seems to be breaking into parts. So really, this is very exciting, and I think it'd be really worth keeping an eye on Jupiter, even from our latitude, really trying to observe and image it even at the 15 degrees altitude that it attains from England. This is very exciting to see what will happen to the Great Red Spot. Here's another image from Clyde Foster, and this is in the methane band, so this is in a narrow band of light in the red, about 800 and something nanometers. And there you see, and this methane reveals the altitude of clouds, really. The highest altitude clouds are the brightest in the methane, and so you can see these are very high altitude clouds, and you can see again this splitting off, this apparent disintegration of parts of the Great Red Spot. So this is all unprecedented. And here's another image of Jupiter from, this is of course a Damian Peach image taken with the 1 meter telescope in Chile, the Chile scope, and here is Io in transit and the shadow of Io, and here is oval BA, which has gone completely white recently, and so this is the other side of Jupiter. And here is a map of the whole of Jupiter, compiled. This has been annotated by John Rogers, and the map actually is produced by Mark Vedovato from images by Olivette McNeil and Pierre and Foster. And this just making the point that the Juno probe, which has perigeos, it goes close to Jupiter because the Juno probe is mainly a magnetic probe, and so most of its orbit is far out in the magnetosphere of Jupiter to study that. And it only goes close to Jupiter and takes the pictures once in a while. And this is the perigeo, and we've got perigeo coming up at on May the 29th. And so John Rogers is encouraging people to try and image these longitudes of Jupiter. The probe will come in from this direction, it will scan across here, it will pass across Jupiter like this. It will go quite close to this quite an interesting cluster of white ovals, not well shown in this picture, in this area, but it won't go near the red spot, unfortunately, and so it only sees a small part of the planet at once. So, although this very exciting development of the red spot would be great if we had Juno images, we won't, as far as I know. Juno will miss that part of the planet. So we are entirely dependent on the amateur images to find out what happens with the red spot. So here's an overview of the planets in this summer. Venus is not observable at night now. It's only observable in daylight. It's currently 19 degrees east of the Sun. It's moving towards conjunction in August. It's now magnitude minus 3.9, almost full, phase 0.95, but we're encouraging people to observe it, to try and image it in the mornings, and try and follow it at this high phase. Mars is now disappearing into the western dusk. It's now setting at 11:30 BST, and so it's only 9 degrees above the horizon at dusk, so it's hardly attainable now. Jupiter is visible from about 11 BST in the evening, and it's culminating about 2 at the moment, opposition 10th of June, but it only reaches 15 degrees altitude this year from London. Saturn is following on behind, rising just before midnight BST, but it's only attains 16 degrees high by dawn. Uranus and Neptune are both too close to conjunction to observe. Mercury is not observable this month either. So here is Venus, imaged recently by a relatively new contributor to Venus section. This is Ron Palgrave, and here are his images in infrared light, and these were taken with a Meade LX200 14-inch SCT, and a ZWO camera, an ASI 224, and you can see a very vague hint of the markings, the typical V-shaped atmospheric marking on Venus, one of the permanent markings. So this is so well done, Ron, for observing Venus at a high phase. And Martin, well done to Martin Lewis for following Mars. This was taken at May 21st, and Mars is now down to 4 seconds in diameter, and very low in the west, but Martin still managed to get this image showing considerable detail with his 18-inch home-built Dobsonian, and again an ASI 224 camera. We're not going to see very high-quality images of Saturn from the Northern Hemisphere this year, but this is an image from the Northern Hemisphere. This is Marc Delcroix, I think, from just outside Paris, and he's got a wide image, and he's taken this in 2 exposures, a shorter exposure or shorter a video with shorter exposures to capture the planet, a stacked video, and then longer exposure image to get the moons. You've got 4 or 5 of the moons in there. There's Titan and several other moons there, and that was taken just about a week ago from near Paris. But this is the high resolution thing. This is again the Chile scope, Damon's image of Saturn, and not a great deal of activity. There are no obvious major spots, but you can see the North Polar hexagon. And the ring's very wide open. And I have been sent this recently by Christophe Pellier, which I thought I'd mention. Christophe is another of the very active French group of planetary images, and he's been trying to extract some quantitative spectroscopic information out of his observations of Uranus taken in the second part of 2018. And so here is spectroscopy of Uranus, and he's going to try and do this in future years and trying to see if there's any detectable changes. Spectrophotometry is the term he's used, and there's a long explanation on his website there about how he's derived those results and how he's calibrated it. We do have a minor planet coming to opposition. That's tonight, isn't it? May 29th. Ceres coming to opposition, and it's magnitude 7. It'll be 20 degrees high, and this chart also shows the positions of the other planets in the morning sky at 2:30 in the morning. There's Ceres and Jupiter a bit further around. There's Saturn and also Pluto. And it's one of the BAA website challenges at the moment is in fact to observe Pluto and Saturn and Pluto on the same night. And this is a minor planet here as well, a completely fortuitous one. So it's interesting how you sometimes get these fortuitous things. This is an image of Messier 53 that Robin Scagel took when I and he and some others were on an expedition to a dark sky site in Wales. And here's an image taken with an 80mm refractor and an ASIC 314 camera, and a 50-minute total exposure, and he's got accidentally an asteroid there, and he detected that because the movement has caused it to move between the red and the blue exposure. So you've got a spectrum there, and that is the asteroid Unica there, captured by chance. I'll mention one occultation of a star by an asteroid. This is highlighted in the BAA handbook as a good one. This is July the 26th. At just past 1 UT. This is an asteroid called Comachina, and it occults a star which is 11th magnitude, and there'll be a big magnitude drop of 3.2, and this will occur south of this line. So in the southeast of England or in northern France, there's a chance of observing it. These things are always a little bit uncertain, although they're more and more certain these days because we've got very accurate Tycho and Hipparcos star catalogues now, but there's still a slight inaccuracy due to the variable elements of the orbit. But it looks like it's very, very good chance of being seen in Kent and Sussex. And observations of these occultations from a number of stations allow us to deduce the shape of the asteroid, or one view of the shape of the asteroid from the different timings of the different lengths for which the star is obscured by the asteroid as seen from different locations. This was a thing posted to the BAA website in the last couple of days, and I thought this was a very nice illustration by Andrew Jeffreys of light pollution. He's taken his Canon 6D camera and he's taken exactly the same exposure, 30 seconds under the same ISO and so on, same lens, same camera, in West Wales and East Wales, and this is of course the Orion Nebula. And people don't often do that. You don't often see that direct comparison of what the sky is like. So that shows you what the problem is. And apart from that, of course, as Nick has already mentioned, we'll have the problem of more and more satellites in the sky. There's his image of the Starlink chain, and that's his Sony A7 camera. That's 1/25th of a second exposure there. So this is the news story about that. The SpaceX company has rolled out orbiting broadband system. Cape Canaveral, Falcon 9 rocket launched from Cape Canaveral last Thursday. 60 satellites on this occasion, high-speed connection to the internet. Elon Musk aims to loft 12,000 of these into the sky. And there is much concern in both the amateur and professional astronomical communities as to what the consequences of this will be. And even now it's quite bad. It's for the images that I took on mid-Wales from the trip that I mentioned to you. And these are all quite short exposures. The 20, 60-second exposure in this case. There's the satellite trail, and this, of course, is Messier 81, there 82, and NGC 3077 with a very small telescope, 66mm telescope. And every picture I took has got star trails through it. It's got satellite trails through it. That's Messier 51. Satellite, there's North American Nebula. There it is again. And that was only, this shows you how I've obtained good results from the North America Nebula from London using days worth of exposures, but for that I only required 3 2-minute exposures to get that one. Some people even image satellites. This is rather like, I don't think it should be encouraged really. This is like collaborating with the enemy. But, this is Chris Hooker's image of the International Space Station, taken with his 10-inch Newtonian and a Celestron Skyris 445 camera showing a lot of detail there. If there was an astronaut hanging out there, you'd certainly be able to see him or her. I haven't mentioned our glorious star yet, which has been in a bit of a lull, but there have been some sunspots. Here's a lovely image from one of our most long-term dedicated solar observers, hydrogen. This is a white light image, actually. This is a colorized white light image from Dave Tyler, taken from Buckinghamshire, and this is active region 2738. This spot very, very close to the limb there, and there's been some more spots. This is 2740 and 2741. These two spots, these were seen in mid-May, I think early May, 7th of May. And here's a much higher resolution image by Dave from the 10th of May of 2740, showing the granulation in the sun, a lot of detail in the spot. And another one of the other group, AR2741, showing the bridge across the Umbra. And here's an image of hydrogen alpha of the same spot, AR2741, by Gary Palmer, my Deputy Director of the Equipment and Technique Section, taken with a 6-inch refractor and a Daystar quantum filter and an Altair Hypercam. But this is the Solar Dynamics Observatory image of the sun from yesterday, completely spotless yesterday. So those spots have gone around the limb, and they're only small ones, so they're unlikely to return. So it's still in a low state, but seemingly recovering. I think the signs are that it is recovering, and we're probably not, touch wood, we're probably not entering another Maunder minimum. Here's another thing you can do with the sun. We heard about pinhole cameras earlier and exposure on treated paper, and this is just the same thing done this year. This is a solar can. The solar can is a commercial product. It's just a can with a pinhole in it. It's a pinhole camera with paper in it, with very slightly light-sensitive paper. And Martin Lewis exposed this, stuck it up in his garden and left it there for a year, and you get a record of the path of the sun through the year, and you get a record of when it was clear, when it was cloudy. And this was the spring period, spring this year, February. It's February. This was February when we had a period of very clear weather. So that's a nice simple experiment you can do. The solar can. Currently, comets I usually try and list those brighter than magnitude 12, and there are none. Looking ahead, Jonathan Shanklin tells us that the next comet likely to become visible in binoculars maybe 2017 T2. It's been observed in March and April by Gonzalez, brighter than expected. It's gone into conjunction this month, and we hope to pick it up again at the end of June, from the UK slightly later, the end of July, and in September it becomes well placed, and it may remain well placed until 2020 October, and it will become circumpolar from the UK. So here's some projections, and there's always a huge amount of uncertainty and a huge pinch of salt. Possibilities in these models is that it could get to 7th magnitude, or it could get to -4. You never know. So that's likely to become visible in the second half of this year, 2017 T2. Here's a recent comet image. This is a faint comet, magnitude 11, 2018 R3, and David Swan has imaged this with his 8-inch hyperstar system and an ASI 178 camera, and it's been in our outburst. It would have been fainter than that, but it's had a bit of an outburst to magnitude 11. Meteors. There are a lot of meteor showers at this time of year. It's a good time of year, and it's quite warm, so you can lie out or sit outside and stare at the sky for a long time. But the first ones I mentioned are in the daytime, so you can't do that. What is the interest of a daytime meteor shower? Well, you can observe it by radio. The daytime iridids are observed by their radio reflections. You can monitor a transmitter somewhere around the curve of the Earth. The usual one they use is the Grave radio transmitter in northern France, and you detect the reflection of the ionized trail, the reflection of the radio being off the ionized trail of the meteor, and you detect that. So after that we've got the June barotids, which is a minor shower, but it has sprung surprises occasionally. It has had a ZHR of unexpectedly 100 in an outburst in 1998, and it's favourable this time round. There's no moonlight interfering with it, so that might be good, or it might be a non-event. Then we have the Delta Aquarids, which occur towards the beginning of July, and that is, the maximum at the end of July, in fact, and that has a favourable, again, there's very little moonlight, ZHR of 20, maximum rate of 20. The Perseus, of course, the most famous meteor shower of the year, and one of the richest, the second richest, but unfortunately this year, when it comes to maximum at August the 13th, it's unfavourable because the moon is 13 days old, so it's it's nearly full, so that'll somewhat wash them out. But theoretically, you could get up to 80 meteors an hour if you could scan the whole sky, which you can't. Here's a thing which has been discussed a little bit on the BAA website forum recently. This long period nova, which is called AL Coma, it's very near M88. It's a lovely spiral galaxy. They're seen here in this very nice image by Mike Harlow, remotely remote controlled telescope, the 0.5 metre Gemini telescope, and that only required 180 seconds. But this is the thing of interest. This is this long period dwarf nova, and an outburst was detected by this Japanese observer, Moriyama, on April 14th, and BAA members have been monitoring this since. And here's some historical data compiled by Gary Poyner of ALCOM, and this is an outburst which was well observed at that time, and it faded away from the outburst, and then it had subsequent recoveries, a recovery here and a recovery here. So Gary makes the point that it's worth following this for several weeks to see if it has any of these subsidiary maxima. At most that was about 11th magnitude, but I think now it's gone down to about 14. So it's very, very much a CCD object. And Robin Ledbetter has even secured a spectrum of it, which shows hydrogen alpha and hydrogen beta lines with his LP600 spectrograph. Another variable star campaign, which I've been asked to mention, is Nova Lyrae. Lyra is, of course, high up in the summer sky, and it's virtually overhead at midnight in August, when the skies are just about dark at midnight again. Nova Lyrae was discovered in 1919. It was magnitude 6.5 when it was a nova, when it was discovered by Miss Mackey at Harvard, and it has been around magnitude 16 ever since, but with subtle variations. It has a variation of about a magnitude, and it has nearly linear rises and falls on a 100-day timescale, occasional 0.5 magnitude outbursts. So the campaign is to observe it intensively, and we want nightly photometry, we want time-resolved photometry, and spectroscopy is also useful. And so this is the ongoing campaign, and we want to get as much detail on the behaviour of this old nova. So old nova is not well studied, and they attract attention when they're novae, when they're faded from view, people forget about them. So we could well learn something from studying Nova Lyrae. Again, 100 years, the centenary project, 100 years after it was discovered. Of the many deep sky images that have been submitted to the BAA community page recently, I thought I'd pick out this one, the antennae galaxies, NGC 4038 and 4039, one of the most famous examples of interacting galaxies, imaged by Peter Goodhue from his Dark Sky Observatory, which he set up in Spain with a 6mm refractor and a very expensive camera, a QSI camera, and 21 hours of exposure. But in its own way, this somewhat messy-looking image is even more impressive. This shows some of the globular clusters in and around Messier 81, so the globular clusters of Messier 81, and this is an image by Paul Leyland, and he used another remote telescope again, a 0.4 metre telescope, and an ST8 camera, and many short, I'm not sure if it was a remote telescope actually, come to think of it. Anyway, there's many short exposures, many 30-second exposures, and then there's a whole big article on the website at the moment, it's linked to the front page, as to how we actually identified these globulars, and you see some of them are quite clear in this image, and some of them are dubious because they're almost at the level of the noise in the image. But there is, at least there's something like 50 of them there. And I've never seen that done before, with such a distant galaxy, with amateur equipment picking up so many globular clusters. So that's just about it from me. I thought I would end with another very aesthetic image. Janice McLean went to Rathlin Island off the coast of the north of Ireland to observe the puffins, I think, and seabirds, and captured this lovely double rainbow. So another, not an astronomical phenomenon, but another picture of great artistic merit, and again this indistinction between the land and the sea, which I like there, which we had right at the beginning as well. So I hope you all have a good summer. I hope you find things to observe and astronomical activities to do, particularly after August when it starts getting dark again. And for those off on the solar eclipse expedition to Argentina, I wish you clear skies there. Thank you very much.
Well,